Okay, so let's do some examples with the graphing on a coordinate plane. So write down these two examples real quick, and we want to make these look like one of the two standard form equations that we just did on the first video. And so when I look here, I notice that this guy's pretty simple, but I need to move the x value to be over here with the y value because that's how it looked on both of the standard equations that we were doing. And so when I do that, I end up with x squared plus y squared equals 25. And now that looks like the standard equation for when it's centered at 0, 0, because I'm not seeing anything here with an h and a k, and so I know I'm centered at 0, 0. And remember, this is my radius squared, so I have to think about taking the square root of that, and so I can see that my radius is really 5 units. And so I'm going to be centered at 0, 0 and have a radius of 5, which means if I go, straight vertically or horizontally, I'm going to go 5 units. I can't count 5 units diagonally, only, straight upwards 5, horizontally 5, downward 5, and left 5. And then I can sketch. I knew I could do 5 in any way, 5 units in any way, because radius is the same all the way around the circle. So even though I cannot count 5 units diagonally, I do know that if I came up diagonally that this would also be 5 because the radius is 5 all the way around. All right, when we look at this second example here, remember, we can see here he is not being centered at 0, 0. Okay, this is going to tell me my center. Remember, it's opposite signs. And so it's going to be centered at -7, -8. Again, remember, this is your radius squared. So to take it out of the equation, I'm going to have to take the square root. So my radius is going to be 8 units in either direction of the center. So centered at -7, -8 would be down here, and a radius of 8 means to go up 8 units, to the right 8 units, and I can't really go down and left, and so we're just going to kind of sketch this circle here. Okay, maybe your circle can look a little better than mine, but something like that. And I usually like to denote on my pictures that the radius is 8 units there. Okay. All right, you probably want to pause the video here so you can write down these two examples. But here we're going to be writing the equation. So here they say that this point here is on the circle and it is centered at the origin. So I like to draw a picture here to kind of understand what's going on. If I'm centered at the origin, I'm centered at 0, 0, and this point 1, 4 is on the edge of the circle, then the distance between those two things would be my radius. Notice I said the distance. And so what we're going to do here is we're going to use the distance formula to figure out how far is it between those 2 points, and that'll give me my radius, which I need for my equation. Remember the distance formula from earlier in the school year? The difference of your x's squared plus the difference of your y squared, and then don't forget at the very end to take the square root of that. And so this is going to be easy though because I'm centered at 0, 0. So 0 minus 1 squared and 0 minus 4 squared is going to give me the square root of 17. And the square root of 17 is about 4.1. Okay, but actually, for writing the equation, we want to leave it in radical form. So we're going to understand it with that guy there. All right, remember, centered at 0, 0 means I'm using this equation. Okay, because I'm centered at 0, 0. And my radius, when I put it into the equation, needs to be squared. Well, my radius right now is the square root of 17. And so I need to square that and simplify that to formally write the equation. Well, if you put in the calculator the square root of 17 squared, it's going to tell you just 17 because technically square and a square root cancel each other out. Phew, excuse me. And so my equation for this guy would look like that there. Okay. All right, we're going to use a similar thing for the next one. This one's a little easier. Here they're telling me the radius is the square root of 30, and they're telling me it's centered at 0, 0. So again, since it's centered at 0, 0, I know I'm using the more basic equation, which starts off like that. And all I have to do is figure out what my radius is and then square it. Well, I know what the radius is. The radius is the square root of 30. So when I put that in there, again, when you square a square root, those just cancel each other out. And so my equation here would look like that. So the most important part when dealing with circles that confuses people all the time is that when you are looking at the equation, this is your radius squared. To take it out of the equation and understand it kind of like in real life, you have to take the square root of whatever you see there in your equation. You probably want to pause the video here to write down these two examples. All right, here they give me the equation. And remember, this gets a little confusing because it was like opposite signs and stuff. So what I want to do right now is I want to understand what is his center currently like in real life, not with this whole opposite sign thing. And so he would be centered at positive 16, positive 6. That's his center currently right now with a radius of 1. If I translate this left 4 and up 2, you have to think about, is that going to affect the x value or the y value, and when it affect it in a positive way or a negative way? If you move left on the graph, that's affecting your x value, and moving left means I'm going to be subtracting 4. If you move up, that's going to affect your y value on a graph, and that means I'll be adding 2. So I'm going to come over here to my center, and if I move left 4, that's going to affect the x value. So I'm going to subtract 4 from the x value. And if I move up 2, that's going to affect the y value. So I'll be adding 2 to that y value. So this is going to be changing where he's centered at. And so this is going to give me 12, 8. I'm not changing the radius because I'm not stretching it or shrinking it or anything like that. So when I go to write the equation for this new center, that's his new center, then I know it's just going to be x minus 12 squared and y minus 8 squared, because remember when you put it in the equation it has opposite signs, and I'm going to keep the same radius that it had above, and this would be my equation if I translate him left 4 and up 2. For the next one, they're giving me the center and they're giving me a point on the circle. So again, if I draw a picture here, I have a center. The one we did before was centered at 0, 0. This one's not. But they're giving me a center and they're giving me a point on the circle. Okay, so I can go ahead and plug in. I know this is my H. This is my K. I can go ahead and kind of get my equation started here. I know this is going to be x minus 2 squared and y plus 5 squared. Everybody okay with why that's y plus 5? Because the equation's always y minus your k value. Well, since my k value was negative 5, if I'm subtracting a negative, that's why I turned that to a positive there. Now all that's left is to figure out my radius and to square him. Well, again, the distance between the center and a point on the circle is your radius. And so what we need to do here is do the distance formula between those 2 points, and that will tell me the radius of this circle that I can plug into my equation. So order doesn't really matter as long as you're doing the difference of your x's and the difference of your y values, because we're squaring it. And so the order isn't really going to matter with the whole negative. So punch this in the calculator real quick. Don't literally punch it, but you know what I mean. And we get the square root of 97. That is our radius. Okay, so remember when you put it in the equation, you have to square that radius. And again, squaring a square root are going to cancel each other out. So the equation here would just be that. Thank you.